Start the recording.
Okay, yeah, I just heard the recording's on. So
all right. So we have David and I have managed to obtain host rights for this presentation as opposed to last time where we were just along for the ride.
well, you got the host rights, right?
Yeah, I gave you co-host rights.
Oh, you gave
David.
co-host. Okay.
And what a lovely co-host he is.
Indeed. So let's see. Yeah, so we'll give everybody a few more minutes.
Yeah, let's give a few more minutes while everybody's checking on the game.
And because of the question about the J1772 plug last time, I have a good infographic to show the different plugs this time.
Thank you.
Who's that? Hey, Doug.
Hi, Paul.
Hi, Doug.
Dave.
Dave, Paul, all that. Kathy Stein, good. Kathy.
Hey, Doug, we're getting a lot of noise coming from your. Awesome, thank you. I was starting to think you were going to be wrong, David, about a lot of people showing up, but you seem to be right.
Well, how many do we have? Let's see. I
keep having to expand the window so I can see everybody.
Yeah, I know. How do we? I'm trying to expand it too. How many?
There's another view.
I've been marking people off here, and so we still can have quite a few more. I know there were quite a few that did say they won't be able to make it, but I think we should have more than we did last time.
If you're in a gallery view, and then there's like a grab thing next to the view of the individual, so you can slide over the slide presentation and determine how many people you'll see in that gallery view.
Yeah, I can only see 6 at a time for the gallery view. I'm on a computer.
Yes, slide it over, and then you'll see more.
I've got 10 that are showing up on mine.
Yeah, me too.
Okay.
Yeah, I see 9 plus myself.
So I just see 1, 2, 3, 5, I think.
Oh yeah, you can slide
go.
over
Yeah,
slider grabby thing.
You mean like move my chair over?
Or with the drag with your mouse.
Drag? I don't have a mouse, but I think I could drag with. I'm going to drag.
Okay.
No, I'm just moving all of us over across the screen.
I see 10, including Sean and me.
All right.
Viewing.
I don't know how it works on the iPad. I just used an iPad for the first time today, and it's like, to get used to it.
And there's at least 2 screens that have 2 people, so we got a dozen.
Yes. It's about what we had last week.
Oh,
All right, so we are hitting
Is it
7:03.
7:03? You want to get started or?
Yeah, we can get started. And we are, just to remind everybody, you got a notification when you joined, we are recording. And the church is able to post that link. I don't know if they posted the last one right on the website or not, but
Yeah, it's on the website. Mhm.
okay. So just be aware, if you really don't want to be recorded, then now's your opportunity to jump out and watch the recording later if that's bothering you. Most of you I recognize from the last class. I know a few didn't get the link or weren't able to attend. And what we talked about the last time, if you didn't get to see the recording after the fact or didn't attend, was where the like raw materials that come to birth your electric car essentially, and then what happens to those things when the electric car comes to an end. And when we kind of get to the end of this and the questions regarding today's subject material, I'm happy to answer questions still on those, and you can always email me to throw my email into the chat here, and I'll have it at the end as well. But today, what the plan to focus on is, while you're owning the vehicle, there's the question, of course, of how green it is. That's thankfully a pretty simple question to answer, like in terms of driving it versus driving a gas vehicle. And then there's, I'm sure a lot of you have questions about what is it like to actually own an electric vehicle, and that came up a lot the last class too, a lot of questions regarding that. And Jim and Fred had a great question regarding the charging plugs, and so things like that too. I want you to feel free to raise your hand and unmute and speak out if you have a question, or throw a question in the chat anytime during the talk today. I'm not intending to just lecture endlessly, and then of course at the end I'll be able to answer questions too. All right, and I'll go ahead and get started. Just a brief reintroduction of myself. My name is Sean Fountain. I'm a mechanical engineer. I also do electrical engineering. Most of my career has been working on electric motors, but the beginning of my career was in plug-in electric and plug-in hybrid vehicles. And I was mostly working on trucks, things for like PG&E utility trucks, buses. We did do some small taxi cars and stuff for Chinese customers actually. And then that led me into the electric motor field. And then now, and I worked with lithium batteries and other components in cars. And this is when you couldn't, as a company, you couldn't go and like buy like an already built battery that was ready to go in a vehicle. Companies would sell you something, and then you'd inevitably have to take it apart, fix problems. It was like really early in the industry. Now I don't work in that field anymore, but I'm very passionate about alternative energy vehicles still, and I'm happy to share that, what knowledge I have of that with you guys. I'm just going to go over this very briefly. This is not specifically an EV thing. This is just a concept pulled from something called permaculture, and it's the idea of separating your world into what they call zones, which is like how important it is to you in your daily life. So zone 0 is like your home. That's like something you encounter every day. And as the zones go further and further out, it's less important in your daily life. And it's not that it doesn't exist. And we're kind of talking 7th principle stuff here. So everything is interconnected, and even something that you only interact with once a month, it's still part of your life, and it affects you sometimes much more directly than you realize. And then I've broken down the zones here for you as an EV owner, and we'll just kind of breeze through this because we talked about the last time. But the zone 0 being, in my idea, being like the actual driving experience of the car. going all the way out until the point where you're wondering about like, where does the stuff come from to make that car, and what happens to the battery when it breaks down and stuff like that. That being something people think about really far away from them. And we talked last time about how the massive amount of copper or lithium that goes into electric vehicles and the electrical network to charge them is something that affects your daily life, from the lithium in your cell phone batteries to the copper in your electrical wiring and your water pipes in your home. It actually does have a direct impact on that sort of zone zero space where you deal with every day. And so I love the seventh principle. And so that's like connecting back what you think of as really unrelated to your daily life is actually very much related. And so you can't ever go, I threw that in the recycling bin and it's not my problem in any way, shape, or form again, you know, with anything. Because if that plastic bottle goes out into the ocean or sits in a dump,
Exactly.
it's there and it's affecting your daily life in some way, shape, or form. And so I like to challenge people to think about that, not just with your electric car, but everything you encounter. And so we already briefly mentioned we're going to talk today about owning the electric vehicle and is it more green while you're driving it? I didn't make a specific slide for this, but I also want to talk about the gas tax question. That's a regulatory issue. And I think everybody who drives around and feels like I-5 needs to be better maintained, this is a important issue.
Right.
Kathy, George, I just want to ask if you could mute, just unless you have a question. So we talked last time about raw materials and end of life, and we'll talk about the use and ownership of your vehicle today. Does anybody have a question at this point? Okay. So this is the basic components of an electric vehicle that are different from your gas vehicle. So the motor has replaced the engine. Instead of burning fuel, it's now spinning using electricity. I misspelled it here, but the reducer that they label here in the picture, that's like your transmission in your car, but it is stuck in one speed. So it's kind of like being stuck in third gear all the time with a really huge engine behind that third gear. And then the batteries replaced your gas tank. Not many people have a good idea of how big a gas tank is, but a battery is physically much, much larger than your gas tank for less range. Gasoline has a huge amount of chemical energy. I should have thrown in a specific number here to show you guys, but it's 5 to 10 times the range per volume and weight versus a lithium battery. And that's even after the gasoline engine turns most of that into heat. So a lot of people don't realize a gas engine is usually about 50% or less efficient. So most of the energy that's in that gasoline is just used to sort of heat the engine, which is actually a problem. And so you have your coolant and the radiator and everything just to keep it from melting itself. Of course, if you're cold, you take a tiny, tiny bit of that to warm yourself up in the car, but most of it's just wasted. So motors are very efficient, typically in the mid 80% to very high 90%, and that's including the battery. So that's like, they call that round trip. It's like from the tank being the battery all the way to the wheel. So it's very, very efficient, but you can't get as much range in that battery. And so that's why you don't have 500-mile or 1,000-mile range electric vehicles, you know, that are just as inexpensive and lightweight as a gas vehicle. Maybe not yet. Maybe we'll have that, but not currently. A lot of people, I'm going to note about the onboard charger that they put here. A lot of people think of the plug that you put into the car as the charger, that thing on the wall, and that's kind of like a switch that has some intelligence, and it talks to your car, and your car says, hey, I'm ready for you to connect the electricity. And that's just like putting wall power. It's usually like 230 volts, like goes to your dryer, if you have an electric dryer. and it just connects it to the car. The actual charging thing is on the vehicle. They call it an onboard charger. And it takes that alternating current, which is pushing back and forth, and turns it into a direct current, which is all flowing in one direction. That's what batteries generate. So batteries can't work on alternating current. So if we use a battery, we have to convert it. And then the electric power control unit, it's also, people would also call it an inverter or a motor controller, is taking that direct current from the battery, and it's converting it back into alternating current in a controlled way for the motor. And that's changing it. So it's not like on your wall plug here in the United States, it's going at 60 hertz. So 60 times a second, it's wiggling up and down the voltage on our wall socket. But with an electric motor, it's changing based on how fast the motor is going. And it's also doing other things to control so that it's controlling how much electrical energy is going into the motor and or out of the motor. And so that controls how much torque or braking the motor is doing. So it's not like just a fixed wall plug. It has to be, even if there wasn't a battery that required direct current, you'd still need a motor control unit. So you can't get rid of that. So those are the basic components in a car that you won't, in an electric car, you won't find in a gasoline vehicle. A big question about gas versus electricity. A lot of people on the internet will throw out, well, you're running your electric vehicle off of coal, like dirty coal power. And that is substantially true for the United States grid. We are in a big shift. Natural gas, you know, sometimes is produced and obtained via like fracking and other things that have brought environmental damage. But in terms of CO2 production, comparing to gasoline, which is also sometimes produced with the same environmental damage by obtaining petroleum, the natural gas is much cleaner than coal. But this number here of 54% cleaner in terms of CO2 than gas vehicles per mile, that is based off of the overall US grid. So that's a largely coal powered electric car. And the reason there's a good, you might ask, or I'm going to ask for you, how could a coal fired power plant be cleaner than a really high tech efficient gasoline engine? Maybe I've got a turbo and I've got a catalytic converter and I've got all these things in my, you know, and it's absolutely true that there are coal-fired power plants that are really not very modern. I mean, they're always having to modernize to some degree. But there are very old power plants that are not terribly efficient. And yet their efficiencies, a not very efficient power plant is still efficient in the 80% or better. So it's making a lot more electricity for the amount of coal or chemical energy going in than the best internal combustion engine can do with gasoline. And that has to do with the type of process. Power plants are essentially a big steam generator. So it's a turbine instead of a big piston engine, but you can think of it as like a steam engine. Steam engines can actually be really, really efficient. And now you think, I'm not putting this on an old train or something. I can build a huge building that's so insulating that it's not leaking all that heat out. And heat is what I'm using to make electricity. So I can keep it all in there and let it be 10, 20, 30 times the size it would be if it was like a gas engine in a car, but I can make it way more efficient. And you could do that with gasoline, but you could never drive your car around at freeway speed if you built your system that way. So power plants, even using the most dirty sources, are way less polluting per mile when they're charging an electric vehicle than driving the most efficient, lowest polluting gas vehicle. That's not to say that modern gas vehicles aren't very good. They produce dramatically less than vehicles even 10 years ago and 20 years ago, small fractions. So if you're in a situation as a buyer where you say, well, I could buy an electric vehicle and that's going to supplant some of my driving, but Other times I'm going to drive my 20 or 30-year-old gas vehicle I already have for like longer trips. Or I could buy a newer, more modern gas vehicle. You may actually pollute less to buy that gas vehicle that's more modern, because it could be a tenth or less the emissions per mile than your old gas vehicle. So that's something I didn't put specific numbers in here because it varies widely across vehicle models and years until the last 10 to 15 years or so because of emissions control standards. So you kind of have to search that on a per car basis, but those numbers are out there. The EPA CO2 production numbers are out there for individual cars if you are Googling information about the car. So if you are producing your electricity mostly from solar or wind, maybe your grid provider like SMUD is going, I think it's 2025, they said. They're going to be fully green, mostly solar and some wind. Or you're doing it at home with solar or wind at home. That's not producing any CO2 emissions. It's not producing NOx, which is what your catalytic converter is there to break down. And that's combinations of nitrogen and oxygen. There's a couple different oxygen count numbers. So it's not like NO2, or just NO2 or just NO3. So that's why they put the X there for like different numbers. So NOx is the shorthand for that. Those are very, very damaging, much more so than CO2. So you have a catalytic converter that breaks those down, but you don't produce any of that and have to deal with any of that if you have solar or wind, right? So there's some strip mining that goes to make the materials, and there's a question of what happens to those when they die, which we kind of talked about on a broader scale with electric vehicles last time. But the electricity production is super, super green, right? There's zero emissions while producing electricity with solar or wind. I said we can talk about the end. I did say I'll be happy to discuss hydropower and whether or not it's green. I didn't put any specific slides in here. It's a pretty contentious subject. But if you want to ask about it at the end, I'm happy to have a discussion with what knowledge I have of that. I don't see any questions yet. All right, we're going to get into, so that was pretty easy, right? Your electric car is a lot greener when you're driving it. It's at worst case, it's more than, or it's less than half the emissions per mile of a gas vehicle. That's off the US grid, which is rapidly improving its emissions as a grid. So, you can totally feel good. If you're putting lots and lots and lots of miles on an electric vehicle, you're definitely taking emissions off the road, unless you weren't going to be driving at all, right? Because you're still producing some emissions with the electricity. So we can talk, we did answer this in some of the questions the last time, but not in the presentation specifically. Driving an EV is just in very short, a wonderful experience. And I'll answer that question just briefly in a brief moment here. When you press the pedal, you pretty much get a response almost instantly. So you don't have that lag. I press the pedal, maybe the engine's going to downshift, or a brief moment while the engine starts to react and give you power. So in terms of performance, like you press the pedal and it's like you're playing a video game, it just goes, and it goes the same amount for the same amount of pedal press every time until you get to higher speeds. And even then it's so consistent, you know exactly what's going to happen when you press that pedal. So that's beautiful. There's some contested research, but that suggests that it even makes it a lot safer, right? Because you don't accidentally over accelerate. And also if somebody starts to merge into your lane, it can be much better to accelerate so they end up going behind you than to hit your brakes, because your foot is already on the gas pedal. And especially in an electric vehicle, the response can be a lot faster to accelerate than to switch over to the brake pedal. So that's good. It gives you a sense of confidence. Like, it's just really nice. Electric cars are super quiet. So most of the time, people over their 40s, they've lost the really high pitched tones. So you may not hear any noise whatsoever from the electric motor system. I, in one ear, still hear the high pitched buzzing, which changes with the speed of the vehicle sometimes, or how hard I press the pedal. It gets louder or quieter, but you know, so younger people tend to complain about that. It's still not very loud, even at its loudest, and just kind of sounds like a little high pitched squeal or buzzing. If you think about, like, everybody knows what that 60 hertz buzzing sound is, like if you plug in something electrical and it's buzzing. So that's 60 times a second. And typically the frequency you're hearing with electric vehicles is between 12,000 times a second. So it's very high pitched, or up to the limit of hearing. And so somebody actually, you can't, no human can actually hear them except maybe very, very small children. And then you can turn the air conditioning on. This is my favorite feature here in Sacramento. You can turn the AC on with your remote, or you can turn it on with your cell phone in most vehicles. I mean, and this is important too, because most electric vehicles have leather seats, just because you're already paying a lot of money for it. So they make the interior generally very nice, and you don't lose your skin to the leather seat in the summer. And you can also do that with the heat too. So that's great. So you never have to get in an uncomfortable car unless you're like, oh, I'm gonna just jump in and I didn't think about it. And then I'll pause before we talk about the braking to answer we got two questions here. So the first question was, why do electric vehicle drivers have fewer annual miles than gas vehicle drivers? That's a great question. You know, I don't know the specific breakdown demographically. I would imagine though, we saw, pull it back here. I don't know if you can see, the average age of a new electric car driver is younger than a new gas driver, but the income level is higher. I would suspect that the average driver has a shorter commute. They can afford it. They may be working from home more. They may be semi-retired or retired at an earlier age. And so even though that's an average age, you may have a higher level of semi-retired or retired people driving, despite the lower average age. But you may be a lot more conscientious of your driving habits. I certainly know, as having been an EV owner since 2014, you definitely think a lot more. Range anxiety, which I have a notation in the next slide, I think it is a big thing that makes you go, do I really have to go there today? Am I making a trip for no reason? And even though it's so much cheaper per mile to drive, if you ignore the cost of the vehicle when you bought it, just that electricity cost is so cheap, you go, oh, well, it's really cheap to make that trip. You still go, oh, but that costs me money. I don't know. You get like weirdly miserly, at least in my experience with myself and other EV owners I've worked with and known. You kind of get really miserly about using the electricity and having to recharge the vehicle. Oh, that place makes you pay for the electricity, so I don't want to go there, even though I might normally do that, you know, for lunch or something. So maybe that has something to do with it. I don't know. I'm just guessing here. And then the other question is there a learning stage to accelerating? I find that most people get it like right away. I've been in a lot of cases where we were giving prototype trucks, like big vehicles, to people who were replacing giant diesel engines in these trucks that have huge amount of get up and go when you press the pedal. And we were replacing with electric motor systems, and they were always afraid of this learning curve, for the acceleration learning curve, that they were going to like end up like taking off like crazy, or it was going to be gutless and it was going to be horrible. And it's like usually within 5 minutes, they're like, this is so easy, because again, it's like you press the pedal and you get the same response every time. Whereas with a gasoline vehicle, you got to get used to how the transmission is shifting, particularly if it's an automatic. You know, so how does it feel in first, second, third gear? When is it going to shift? So there's a level of unpredictability that takes a while getting used, you know, getting to know that car. And that can even change if you got into your friend's car that's exactly the same make and model, but it has more miles, or it's not cared for as well, or it's cared for better than yours, it will also behave differently. And all cars nowadays, and now since the mid 90s, for the most part, they kind of learn your driving habits. So if you are someone who has a really heavy foot, the car will accelerate much more aggressively depending on where that pedal position is, because that's what you're asking. You're going like, I'm only slamming the pedal down because it's not giving me enough acceleration at small amounts of press. So the car slowly adjusts what that pedal gives you. And that's true for gas and electric vehicles. But again, with the gas vehicle, there's all that other unpredictability in it. So even if you get in someone else's EV and they have a lead foot and you don't, you learn very quickly exactly what's going to happen when you press that pedal. So it's a lot easier to adjust, I feel. Decelerating is the stage where there is a lot more learning curve. And that brings us back to this point here of braking. Most of the braking you'll do in an electric vehicle, especially because you're trying to extend your range and be more efficient, is what they call regenerative braking. That's when you're using the electric motor to slow the vehicle down, and it's acting as a generator. It's putting electricity, basically taking the energy of the movement of the car, and it's putting it back into the battery with a really good efficiency. Now, that doesn't mean you can just accelerate and slow down and drive an infinite distance. Most of the energy you're using when you're driving the car is lost to the wind, fighting the wind. So you're shoving wind or air along with you all the time. And that takes a lot of energy. And obviously that's not bolted to your car, so you can't absorb that back when you slow down. You also use some energy, although it's not a big amount, making all the bearings and wheels roll. And the tires are actually designed to stick to the ground, like literally stick, like they kind of very lightly glue themselves to the road. That's part of how they grip. And so when they're rolling, that back part has to get ripped up off the surface, and it's very minor. It's not like you put duct tape down, but it's enough that it has to use it, and it warms up the tires in the process. And that anytime you're making heat like that too, you can't get that back. It's lost. But the regenerative braking gets you back a fair bit. Typical numbers we used to use with the trucks was 10 to 30% of a truck driving cycle. Now, trucks are full pedal slam to the ground, take off as fast as you can because it weighs so much. You got all the tools in the back, probably more than you're supposed to have weight-wise on the truck. And you're pulling a big trailer because this is like PG&E trucks and stuff we were dealing with. And then you would slam the brakes really, really hard when you get to the next location. Because again, what looks from the outside like not very fast is like pushing those trucks to the limit. Those utility truck drivers are often really, and bus drivers too. Garbage truck drivers, mail trucks, these are all examples of, you see this with like Amazon drivers. They're often not carrying as much weight, and they have relatively high performance vehicles. So you see that FedEx or UPS truck or Amazon truck is really driving like a mad person. Well, your garbage guy is doing the exact same thing. He just doesn't have essentially as much hot rod there compared to how heavy the vehicle is. But he's pushing that vehicle to its limits every time because it's all about less time. Time is money. So you as an EV driver is probably not driving that way. So you may get on that 10% end back from regenerative braking, a little bit more if it's all stop and go city driving, and next to nothing on a freeway because you're not slowing down, everything's just shoving the air along. One thing to consider with electric vehicles is because the batteries are really big compared to a gas vehicle, they're very heavy. They can weigh anywhere between 500 to sometimes almost 1,500 pounds more than a comparable sedan, for example. And they're on essentially the same wheels as the comparable gas vehicle. So there's the aspect of tires wear out a fair bit faster with electric vehicles.
Hmm.
But you pretty much never replace the brakes. So it often comes out as a wash there, if not a savings in your end. But the tires will wear out faster. And when you're going around corners and you can lose traction like ice, snow, wet conditions, electric vehicle, and you'll feel it, is a lot less sure-footed than a gas vehicle. You can throw tires on it that are a lot more sure-footed and stuff, but you'll lose range because those tires stick to that road a lot better, and so it has to work a lot harder to roll them.
Sean, may I comment on, again, the pedal control a little bit?
Yeah.
Because in our Volt, and I'd like to know how common this is among full electric vehicles, but in our Volt, when I'm driving in city or even congested freeway traffic, I often put it in low instead of drive. And actually, Chevy promotes this, where it enables me to slow down without actually even having to touch the brake, gently slow down.
Right. Yeah. So different vehicles have different strategies or different manufacturers. So the Chevy Spark that I owned and the Chevy Volt, they had this low selection. So you had a gear selector just like an automatic, and it was like drive or low. And you also had neutral and stuff, which is so it can be towed up into a tow truck and stuff. But the low tells it to do the motor, the regenerative braking much more aggressively and down to a lower speed. So get as much electricity back as possible. What happens there though, is when you lift the gas pedal off, is it starts braking, not really hard, but a fair bit. And a lot of drivers they found did not like that initially. So they would leave it in the regular drive is like the sort of like normal driver preference, where it only very lightly slows your vehicle down with regenerative braking. And then if you press the brake pedal and it depends on the car, for the first like 10 or 20% of the pedal, it feels a little different, and that's on purpose, so you know. And it's just telling the motor to brake harder. So in that way, in like Chevy vehicles, that's how they did it. I believe the Ford Focus and stuff is also the same. Tesla, I don't know if they were the first, but they were the most prominent to introduce what they call one pedal driving, which is that the regenerative braking provides almost as much braking as the vehicle can possibly sustain, right? So that's a lot. That's like you hit the big brake pedal really hard, and it does that when you let the gas pedal off. So, and they tune it so it's not immediate. So it's not like an emergency braking situation. You let it off and it will keep increasing the braking if you keep your pedal off the foot, and it will bring the car to a complete and pretty firm stop. It'll even bring the car to a fairly firm stop if you're lightly pressing the pedal. So in that way, they have kind of like a super low. If you were to look at the Chevy version, that's just the default all the time. And they said drivers just get used to it. And a lot of the other manufacturers have adopted that, including Chevy in the Bolt with a B rather than the Volt with a V. So some of them give you paddles or buttons, and you like the Smart for 2 electric has buttons or paddles depending on the model you buy that can change how strong the default regeneration is. But that one pedal driving style, it ended up winning out. Drivers did have to get used to it. Very different. Yeah, I mean, nobody expects their gas vehicle to come to a complete and pretty firm stop if you let the pedal go, right? It'll keep rolling on its own, but people get used to it and they adapt and they prefer it in the end. There's a question. Yeah, that not all EVs can come to a complete stop on the electric motor. So they do have a standard disc brake system. So when you press the pedal down far enough, if they have that motor control on the brake pedal, or some vehicles don't have any motor control on the brake pedal, if they have that one pedal system, you press the brake pedal, it's pressing your regular old hydraulic disc brakes. And that's a quote unquote dumb system. It'll have ABS and stuff like that, which adds some intelligence to prevent, sliding, but it will work even if the car is off. So that's an important safety requirement for all vehicles on the road. The hydraulic system works even if the car is off. So in a gas engine vehicle, brakes don't work as well if the engine is off. And that's because the engine has a vacuum, a big giant drum, essentially a diaphragm, and when it's sucking air in, it's applying vacuum to that drum. And when you press the brake pedal, it acts as like a big amplifier and makes your brake pedal press that much harder to the hydraulics in the brake system. And that's why you can, they say pump the brakes if you don't have ABS. Well, the same goes true for if your engine is shut off, you can pump the brakes and build brake pressure. Same with electric vehicles. They actually have a little electric vacuum pump that's just there for your brakes, or sometimes they have a fully electric non-vacuum based brake booster. But it's the same thing. If like for some reason you lost power on your electric vehicle, you can still press or pump and press the brake pedal and come to a stop with the disc brakes, and they're just the same. The nice thing about electric vehicles is when we let the Spark go last year, because we just weren't driving anymore with 5 kids and only seats 4, and then during the pandemic I wasn't doing any commuting. It had yet to even wear a quarter of the way through its original brake pads. So and it had a lot of, I think it was like 42,000 miles or something like that. So it was like not even a quarter of the way through the original pads, whereas our station wagon, that's our primary family vehicle, in that time would have had at least one replacement of the pads. So you just basically never replace brake pads on an electric vehicle, which is really nice, unless you got a super lead foot on the brakes. Does that answer the question, Steve?
Yes.
All right. Okay, so owning the EV, these are the things that will like be in your mind. If not right off the bat, then often after you've been driving a bit. Range anxiety is the big one. Even if you have a car that has 20 times the range you need for your trip, it takes quite a while for people to get over the idea that they're going to run out and get stranded. You build confidence. If you're like me and you're an engineer in the industry, you build overconfidence and you do get stranded sometimes. And then you learn to dial it in. Most people stay really shy of ever running out, but they feel afraid. And this comes up in study after study. They feel afraid that they're going to run out of electricity and get stranded. What most people say in the studies I've read is mostly that there isn't a lot of places to park and charge. And then where there are, often you're kind of fighting other EV drivers to park and charge. And it's like so often the guy, no offense to Jim and Fred, with the hybrid, the plug-in hybrid Volt, who only has 10 or 15 miles of electric range and can go 300 miles on a gas tank, who just absolutely has to charge, and it doesn't matter that you can't make it home. So it's like, it can be very frustrating. Most of the time people will go, you know what, I'm okay. You go ahead and plug in. A lot of the time you pull up, you don't know where they are. They're in the mall. So, or are you going to go and have them call that person? You would say, oh, well, I'll go find another charging spot. There's just very few out there. That's rapidly changing. There is a government funded on a state and federal level charging network initiatives. So particularly in California, but even across the major interstates throughout the United States, there's tons and tons of charging going in. It's still, 5 to 10 years off before I'd say you're going to be pretty comfortable. And then there's going to be a lot more EV drivers. So I'm interested to see how that's going to pan out. But if you don't ever push the limits, you get over the range anxiety, really, really well, the car is going to go the range, and you don't have any concern. If you do run out of electricity, you can get towed. sometimes AAA or other places actually have a charging truck. So if you have a fast charger, they can come and charge you for like 15 minutes, which might give you like 60 miles or so of range on a fast charger, which is usually more than enough to finish your trip if you're just going home or whatever, or get to a charging station. So there are solutions out there. It's not, you're not just stuck on the side of the road with people laughing at you or anything like that. I got a question is, are there both front wheel and rear wheel drive cars? Yeah. Excepting when you look at like the luxury car brands that usually care less about efficiency and more about, you know, driver opinion. They'll always be at least front wheel drive. And that's because when you're doing that braking, the weight of the vehicle shifts forward and it presses really hard on the front tires, which means those tires can grip really hard. And so you can brake really hard on the front. And the back wheels, the harder you brake, they have less and less weight pressing on them. So you can't brake very hard without them sliding. And so when you're trying to get that regenerative braking, that means put the electric motor on the front wheels. If you want the fastest time to get up and go, you put the motor on the back wheels, because again, when you're going, it pushes harder on the back wheels. And you can think about this like, you know, the extreme version of this is popping a wheelie, or doing the reverse when you're braking really hard, like on a bicycle, and it kind of tips you up over the handlebars. That's the braking version. So you can kind of conceptualize it that way. Tesla offers options, and some of their all their competitors that are coming up are all offering all-wheel drive options. They're mostly a motor system in the front and a motor system in the back, and the back one will do most of the get up and go, and the front one will do most of the braking. And if you're not a really lead-footed driver, it'll be pretty equally split. But you barely ever find cases where even like Mercedes or somebody who would always have rear wheel drive, you barely find situations where they put a rear wheel electric drive only, because again, like they get like almost no regenerative braking, and the EPA estimate for the vehicle range would be terrible. So it's just for the sake of range competition, they wouldn't do it. Deirdre asks if there are portable chargers in development, or is the EV battery so big that this really isn't an option? So if by portable chargers, you mean, are there like plugs you can carry with you to plug in and charge? Almost every electric vehicle will come with one that can plug into a 110 volt outlet. There's usually a spot, in the trunk for you to kind of hide that away. It's about yay big most of the time. Some of them are smaller now. It charges very slow. You can think of it as about depending on how efficient your vehicle is, 4 to 6 miles per hour is the rate it will charge at. So if you're going to go really far, you're probably not going to rely on that. There are trucks in terms of bringing a charger to you that's like literally a power source. There are, like I said, AAA and other companies have trucks that are essentially a whole bunch of batteries on a truck. And then they have a system so they can charge if you have a fast charge connection to do a huge amount of power, they can charge your vehicle from that. And then those can be the equivalent of like 60 to 100 miles an hour of charging, or more in some extreme cases. And there are, even for places that don't have electrical grid connections, they have portable chargers in the sense that they're solar plus batteries that sit in a place. Sometimes they're even on wheels, but they're disconnected. They're off-grid chargers essentially. So they charge themselves from solar, and then they can charge your vehicle there, and it's not using the electrical grid, which often is the big reason we don't have lots of chargers, because electric vehicles actually require a huge amount of electricity. And compared to like your home. And so if you were to charge your electric vehicle as fast as you could, it often exceeds the capacity of your panel, like if you were using all the electricity. So you don't charge like that at home. You don't fast charge at home. And if everybody plugged in a car doing that on a road trip, you can imagine how that's like turning on like thousands of homes for like a dozen cars, right? So it's that's really tough on the current electrical grid. So that's a big reason for the delays in deploying lots of charging. Did that answer the question, Deirdre? Okay, I'm going to assume it did.
I think Deirdre had a follow-up question.
Oh, like
Yeah.
the pack that, yes.
Yeah.
The closest equivalent for that would be a truck that is like a whole bunch of batteries. So it's like a much larger scale. You wouldn't get a meaningful amount of charge in a short period from a small one. So the tow truck driver is not going to come and park for like 6 hours with your vehicle. So from that perspective, it may be possible, but it's nobody's going to do it because it's not like commercially viable. So they have these trucks that have enough battery capacity to be the equivalent of 10 electric vehicles essentially that are on like a trailer or built onto the truck, and then they can charge your car very fast for a short period of time. So Steve wants to know what my monthly bill is because they offer a discount to charge at night. So that discount is great. I believe it's during the summer, I think it's 4 cents from midnight to 6 p.m. And I think it's 8 during the winter or something like that. So it's like dramatically cheaper than your electricity usage during the day. And it goes for everything on your meter. So it's your house and everything. So once we got that rate, we definitely, not only did you can tell the car don't charge until midnight or only charge between midnight and 6. Not only did we do that, but which makes it like $1 or something to recharge your car from a full range use or something. I think sorry there. I think my Bluetooth decided to cut out. So not only is that great, and we did that, but we also did things like set the dryer to only run, set a delay on the dryer, set a delay on the dishwasher. And then what we kind of did was we decided, well, we're going to run the air conditioner overnight too, right? And then it's like get it nice and cool during the summer at night so it stays cool all day. So we also have solar, so we pay annually for our electricity rather than monthly. I think right now our total usage works out to like $60 or $65 a month without the electric vehicle, and it was only like $5 more. It was like almost negligibly more with the electric vehicle, even though it uses so much electricity, because the bulk of our dollar electrical usage is still hot water, air conditioning during the heat of the day, or heat because we have a heat pump. So it's all electric heat during the cold morning or something when we're not on that super low rate. And then we produce a lot of electricity with solar. If I was going to be paying full out for the electricity, I'd probably be paying $250 or $300 a month without the solar, because we bask in the ability to use solar and cheap overnight rates to crank the AC and stuff like that. So yeah, we're using more than we would if not for those things, but it was worth it to us. And then we're offsetting most of our electrical usage with solar. Then there's the question of safety ratings compared to a car such as a Subaru. So so Subaru has great safety ratings, especially when they're including the crash avoidance equipment. Subaru in particular has some really good equipment. My parents actually have one, partially for that reason. I believe Tesla is the only one that has consistently beat everybody in safety ratings, and it's not only their so-called autopilot system and avoiding accidents, but it's also just literally if the accident happens. I don't know the specifics, the inside information of why they're so much safer. All I could say is from an engineering perspective, that's a monstrous task, designing a vehicle of any kind from the ground up. But whenever you design from the ground up, you get to throw all the old stuff out the window and say, what do I have to keep because of regulation, or I have to keep because customers will either expect it or require it. And then everything else in between, I get to throw out all the tradition that maybe introduces like weaknesses in the design. And so, but when you're a big automotive company, what they do is what they call iterative improvements. So they're just making small improvements constantly. So the cars keep getting better, partially because they're told they have to do it, but also partially because it's just a little bit better than last time, to make it more and more competitive. Everybody else is getting better, so I have to keep getting better. So whether it's for ethical, moral, or regulatory reasons, the market will still force you to improve because you have competition. But you don't have to improve way ahead of everybody. You just got to keep your position or get a little bit better. So they just make small improvements. It's a lot cheaper that way. And you get it to market faster that way. But that also means you're building on the old design. So you may still have design elements in your car safety wise now. And again, I don't know the total inside information. That's not my area of specialty, but you may have design elements for safety in your car that were thought of like 30, 40, 50 years ago, maybe even before airbags, before seatbelts, that kind of stuff. And you've dramatically improved it. It's a super, super advanced, refined version, but maybe that's not the best base idea. So that's the only way I could explain how Tesla consistently stays ahead in terms of safety, even when you like crash points out. But Subaru, Chevy's been coming up really well. I know the Chrysler Pacifica had fantastic safety ratings. So like, and better in the hybrid version because they had the crash avoidance available in that they didn't in the gas version. But if you looked at just the crash, like it was equivalent. Often one downside with electric vehicles is the battery is a big, huge weight. The engine is also a big, huge weight in a gas vehicle. So much of your dash behind that is built to keep that engine from crushing you in an accident. So the engine is designed specifically to break off and go under your car in a really severe accident. So the car doesn't have to, use all of its body to slow the engine down. You just let that engine go in a really severe accident. And your car goes over the top of the engine, kind of gets shoved up and over, which is usually a safer way for you to crash than to come to a hard stop. It's better if you went like, say, part of your car with you in it went over the top of the vehicle you hit. That doesn't mean that you're not really in bad shape, but it's to keep you alive, not to keep you, walking away, uninjured. In an electric vehicle, you don't have that issue, but you have the battery. The nice thing about the battery is it's really down low. It's at the bottom of the vehicle. And so if that battery can disconnect in an accident, it's just going to scoot underneath you. And then they just designed the front of the car. So the same thing happens. You kind of go up and over stuff you hit. I don't know, how they compare exactly numbers wise, but most EVs are very safe. There's the safety concern about battery fires. We can talk more about that in a bit, but that's mostly a PR issue than a genuine safety issue. It's not that it's not real. It's just not as likely to happen as they make it out to be, or as dangerous to you as a driver when it does happen. Gasoline also burns, and gas vehicles actually set on fire at a much higher percentage rate than electric vehicle batteries do. But just in brief, electric vehicle batteries are much worse of a fire. They just don't tend to happen instantly. So you almost always have time to even be saved by like the jaws of life before the fire gets going. But once it's going, electric vehicle battery, a lithium fire is pretty bad, but it's just rarely a cause for loss of life. Whereas gasoline can get burning really, really fast because the tank can rupture and there's gas everywhere and it can burn. You can be inside a big inferno in seconds in a bad accident. They build the tanks so that doesn't happen, you know, commonly, but it still happens. All right. All right, I think we answered the questions so far. Okay, so after range anxiety, you kind of do develop a fear of like people who are very upset about electric vehicles. It really has nothing to do with you as an individual, but some people, I don't know why, I haven't had opportunity to talk to them generally, but some people are really upset about electric vehicles. I'd love to know what bothers them, but you know, it's a pretty hostile situation when it happens. It's very, very rare. I haven't had anybody say, come up and vandalize my car, but it's a fear you develop because people will express disdain for it being an electric vehicle. And you don't know where it comes from or what that person's going to do. I've read about and I've heard about people having vandalism, mostly Teslas. But then those are much more common in terms of numbers of cars on the road, and they're also very expensive, right? So there's the luxury car element, as well as it's this brand that is really new and it's that seriously hurting the big American brands. So if you're maybe if someone's feeling very loyal to like the big three American brands or something like that, maybe you're upset for that reason. I don't know, but you hear about it, you read about it. I haven't actually seen it. My car got its doors dinged as much as I think as the electric vehicle, as much as the gas vehicle does. And it's maybe more frustrating when your more expensive EV gets a ding than the less expensive gas car just because of the price difference. But, you know, I didn't see any like vandalism. I've seen vandalism to do with the charging plugs. If the area is not well lit, so this happened in Dixon a lot. When I worked in Dixon, the city was big on trying to get electric vehicle companies to work there. I was working for one and they were hoping others would come. So they kept putting in charging plugs at the city hall and they didn't have a light. So it was pitch black at night and people kept coming and cutting the cords that are out for you to plug into your car. And they thought, oh, they're stealing them, but they weren't even taking them for the copper. This was like during a time when people were stealing copper. They were literally throwing them in the bushes. So they weren't even doing it for money. They were just doing it to just cut the charging stations. So after they replaced it like 3 times, they gave up. And then someone finally said, just put a light there, put a street light there. So they fixed it a 4th time, put a street light there. And as far as I know, they're still there unvandalized. So it was, you know, but like people are out there that will vandalize specifically mostly the charging networks. And you do see that sometimes. You go to the mall or whatever, and for whatever reason, somebody's like taking a crowbar to the charging plug probably overnight, and you don't know why. And it can take a long time for the landowner to decide to fix it. You start to become really aware of where has special parking, where has a charger for you. Even when you don't need it, like you'll just find this if you purchase an EV and especially if you can't drive gas, it's a pure EV. You start going, oh, I'm going to go to that mall because they have working unvandalized charging with parking right up by the near, you know, the front of the mall. Sometimes they're like literally as close as handicap parking spots would be. So I mean, like it starts to feel like a privilege. That may also be another reason people get upset. I don't know, but so you do find yourself thinking about that all the time, and every EV owner I've known has echoed this to me. You really start changing your habits of where you shop, how much you shop, how far you shop. Sometimes you'll go further because you know that I'll be there for like 2 hours. I'll have dinner, I'll shop, and my car will get a couple hours of free electricity and you're like, wow, okay, I saved, 40 cents in electricity from home using the overnight rate, but it's like there in your mind, whether it's valid or not. And people ask all the time, what is it like to own an electric vehicle? They often go, I'm not thinking about buying one. Because if you say, oh, are you thinking about buying one? They'll be like, no, absolutely not. Which is always weird to me, but they're just curious. What is it like? Because it's different and they've never had one. You can rent electric vehicles, but it's hard and they're a lot more expensive to rent. So you can't even say, hey, go rent one, for $30 for a day and try it out, right? It's just, so people want to know what's different. So I would have total strangers come up to me and ask me all the time when I'm like plugging it in, what's it like? Even neighbors in the neighborhood when I'd come home and stuff like that. And then, let's see. The question about when or why would you purchase an electric vehicle? The ideal use case that the EV industry likes is somebody who commutes regularly. And if you look at the average commuter is doing 16 miles. So most people are doing 16 miles or less each way. And so those early electric vehicles that were out there doing 80 miles. Hold on, my battery is apparently about to run out. Let me make sure I'm plugged in here. There we go. Those were more than enough for most drivers. And in fact, the numbers that we were given often by the California EPA was that an 80-mile range vehicle suited the needs of 95% of all trips taken on a daily basis all year. So that's why those early vehicles were targeted around that 80-mile range. So the Leaf was like 60 something miles to start with. The Chevy Spark was 80 miles. And that's because they said, well, that covers almost everybody. But once you accounted for that range anxiety, people being afraid of the car running out of power, even when it wasn't a actually justified fear, but like it's a real fear, people just wouldn't largely buy the 80-mile cars. So it was like a PR market issue, perception issue, but it's absolutely more than enough for most people. I had an 80-mile car. I commuted 32 miles each way with it, which is pushing it. I had the opportunity to charge at work most days, but not always, and I could make it home. Also would visit my parents at Elk Grove, which was like 34 miles or something each way. I would usually charge with that 110 volt plug that comes with it and we'd stay there for like 4 hours or something. So I'd get like an extra 12 miles of range, which was more than enough to make me feel comfortable. And then there's a request to put this in the chat here. Oops. Let me see if I can grab that here. May have to drop the presentation for a second. Give me 1 second here. I'll put that URL in the chat. And I'm going to open that URL up too.
Sorry to inconvenience you on that.
No, that's fine. Let me reshare. It's the juggling of online stuff here. All right, I think this is the right one. Yep, there we go. All right, we should be back. But most of the electric vehicles are, 100 to 200 mile ranges now that you have out there. So that's kind of become a non-issue. Now it's really the big point of not adopting for most people is upfront cost and accessibility to charging when you're traveling around. And that's largely a range anxiety fear again, because most people are not traveling further than 200 miles round trip in a day, most people. And when you do, there's you would still have a rental or maybe an infrequently used gas car available for that purpose. And so there's like a lifestyle change there, with the idea that you can't just jump in whichever car and go for as far as you need, because you can just keep stopping for gas. And that's really the mental change that is stopping people from buying, as well as upfront cost. If you make lots of short to medium range trips, so that you're comfortably within the range, and you do that regularly, then that's a really good use case for an electric vehicle. So even if it's not just a commute, a lot of Uber drivers have been starting to convert to electric vehicles for that reason. People who do like Uber Eats and other delivery stuff too. And even a lot of like your delivery services have been starting to build fleets or buy fleets of delivery vans that are electric, because it's a great use case for that 200-mile range or so. You might want to own it just purely for the ecological or ethical reasons, being greener, full life cycle wise, as well as while you're driving, being greener. And maybe you're willing to pay that premium. You're not justifying it economically, but you're justifying it in terms of your values. And then you might also just buy it for the experience. I kind of got sucked into buying it partially for that. And I had a commute that could just justify it, just barely justify like saving money versus a gas vehicle. So like economically. But the truth is it was probably not the right choice, because once I had some job instability later on, like I wasn't commuting as much and I wasn't justifying anymore, and I still had to pay the monthly payment, so I also wanted it. I recognize now for the driving experience. I went to buy a gas version of a Chevy Spark, and I came out with the electric version that's like 2 times the price, right? So because of that driving experience. So, and I did lots of spreadsheeting to justify it, but in the end, it wasn't really the right economic choice. And then I have a fun graphic. I shared the link, but if you don't want to see it, it's kind of hard to see in a slide. So let me, are you able to see this long vertical?
Yes.
Okay.
I do. Yeah.
So I'm going to zoom in a bit here. So the roadmap here, they did a big survey. This was done by Castrol. So it's by an oil company. And it shouldn't be news to anyone that oil companies really only care about making money. And it's not actually about a loyalty to petroleum products. It's just that's their industry. That's where they know how to make money. And electric vehicles and public perception are really starting to hurt that. So they are looking at getting into the electric vehicle industry, and there's investment in battery technologies. There's investment in power generation and solar and lots of things that seem like totally anathema to a petroleum company, but that's because they're just going where the money is, and energy is their industry. So I just thought this was a cool infographic, especially for you to look at more on your own, but it talks about the tipping points and making a choice. So this isn't about, does it actually make economic sense? This is about like the perception. So at one point, it actually makes economic sense for most people who are driving to work. Even though the upfront price is high, if you can manage to get the car, it usually makes economic sense over the lifetime of the vehicle, your usage of the vehicle. But most people are really considering it once the price gets down to $36,000, which we're starting to hit now with the Bolt and the Model 3. So we've seen a huge uptick in demand for electric vehicles. Another thing that's stopping people is they want to be able to recharge really fast. The problem with this 31-minute charge time is if you have an electric vehicle with a 200-mile range, it probably has a 30+ kilowatt hour battery pack. Now it's running 30 kilowatts for an hour. To get an idea, you're usually in your home only running a handful of kilowatts, even with your refrigerator running and stuff like that. And you maybe add a couple more in there when you're running the air conditioning and a couple when you're running your hot water heater. It's not a huge amount of power that you're using in your home. And to do that in half an hour, you have to run, that 30 kilowatt hour pack has to run 60 kilowatts roughly. So it's, 2, 3, 4 homes worth of power to charge in that speed. And so if you think about, people are generally in their cars as much or more often than they're awake in their homes and using electricity. And so it becomes a huge problem for the electrical grid, which is built to power your homes and not to power 4 homes for every person, just so that they can charge your electric cars. But so people want this charge time. It's not that it's what's needed. It's not that it's what's, number wise, the time that makes sense. It's the perception, right? And that's what's really important in a survey like this. So they talked about most people want a range here. This is, I can calculate this for you, but this is more than 200 miles. If let's see. 430, 469. And then we're going to miles. So it's almost 291 miles is what people basically say they want as a range, which is pretty much what you get on a full tank in most vehicles. Is close to 300 miles, some more, some less. That's a range almost nobody uses except on rare occasion, but perception wise, this is what people feel like they need before they'll commit to buying an electric vehicle. They want there to be easy access to charging, particularly free or nearly free charging. Because if you're going to have a vehicle that costs less to drive, why not make it cost way less to drive on the government dime, right? But it's that's how we all generally start to feel when we are making these kinds of shifts, is we want more and more, in what feels like a positive direction to us as a consumer. And that's normal human behavior, but people want a lot more charging infrastructure. That, I think, is a really legitimate want, though, on the part of drivers, because again, if you're going to be driving a lot and you're going to need to charge, it can be sometimes an issue. You can't guarantee that there's going to be a charger there available to go undamaged with nobody blocking it. And so I think that's a legitimate concern, tipping point on this survey. And then also reasonable is people want more vehicle choices. And who doesn't? I mean, there's not a lot of options. There's getting to be a lot more options, but more options is better from a consumer perspective and for competition. So we're seeing a big flood over the next 5 years, and especially over 10 years. So if you're hanging around waiting, in 5 years, you're going to have 2, 3, 4 times the options. And what I'll say is they will be better, especially like the batteries will be a bit better, but they won't be like dramatic. 10 years out, they might be dramatically better. But 5 years, those 5-year out vehicles, they're already being designed now, at least on paper. So it's unlikely, unless you got a company like Tesla or something who will make changes in a really short period of time that often really bites them and their customers in the butt, and they fix it later. Excepting in those cases, it's generally 5 years. So a car 5 years from now, they're just talking about what they're going to change on the existing car today for that 5 years out. That may only be two model differences out. So that's for an engineer who's just trying to improve an incredibly complicated existing vehicle. That's a really short period of time, 5 years. So, again, like I said, if you're gonna, I'm not gonna worry about an electric car for 10 years. You might see something really different range and battery technology, but not in the 5-year range. But there will be a lot of choices in 5 years. And we can go back to the slides, but we're pretty much done here with the slide. Let's see. Oh, this is the Jim and Fred question. I wanted to include this here. Oh, and I missed the question about what was first attracted me to the idea of driving, owning an EV. So that question, what first attracted me was I was working in industry, doing electric vehicles, and they're just so much nicer to drive. I also was attracted to the idea of saving money. And then I was a little bit blinded to the economic truth by how nice it was to drive. So that's what sucked me in. And it sucked in almost all my coworkers. So our boss had the very first Volt that was sold to anybody. That was an intentional PR move by Chevrolet because they were infringing upon his intellectual property to build the Volt. So that's a different story. So they made sure that when his name was on the list that he got the very, very first one, and they did a surprise news event over it, which he was not happy about, but he had it and he drove it all the time and loved it. And so I got my Chevy Spark, and then 3 of my coworkers within 2 weeks also got Chevy Sparks. And there was the Leaf or the Spark were really the only choices at the time, other than the Volt, but for pure EVs, it was a Leaf or a Spark. And then David wants to know if EV price will come down due to mass production. For sure. The big cost elements are the engineering design effort, which for a vehicle is expensive, the investment in production. So what a lot of people don't realize is before they can even make a body panel for a car or a dash or even a little piece of plastic that goes like on a button, if it's unique to that car, there's hundreds of thousands of dollars invested in just cutting blocks of metal in order to shape and mold those materials. And that's after you've paid hundreds of thousands or millions of dollars for engineers to design the whole thing and all those individual pieces. And you've maybe even cut big expensive blocks of metals to make prototypes. So by the time that first one gets sold, there's often, tens or hundreds of millions of dollars in that car. And then they have to spread out across every version of the car. That's another reason they don't do ground up design all the time. They want to reuse as much of that as they can, keep getting their money's worth. And when they're only selling 1,500 or 5,000 or 10,000 of a particular electric vehicle, they don't ever make that money back. Now, when they're selling, Tesla's selling hundreds of thousands, they're hitting that tipping point for a manufacturer where all those costs, those design costs are starting to be almost nothing in the cost of the car. And it's just, can I make it right now, buy the stuff, do the work, and sell it to you for a profit? So you will see prices come down, and there's a limit to how low they can get unless they figure out a way to make it cheaper or they can buy the stuff for it cheaper. And that's something the manufacturer's always working on. Batteries right now are at a big bottleneck because everybody's fighting over lithium, everybody's fighting over manganese and other materials that go into batteries, but guarantee that'll be resolved. They may do that by making a battery that doesn't use as much of those materials, or they'll just resolve it by the mining industry finding and mining more materials. But so yeah, in 5 years, I expect that there's quite a lot of options under $30,000. Where are they going to get down to $20,000? That might be a 10-year window for that if cars don't just get more expensive because people stop owning cars as much. That's another thing that may happen. So we got the plug types. The J1772 type 1. This is what you're going to find on most, or the type 1 and type 2 are going to be on most vehicles. The type 2 is for 3-phase power. So most people will only know this if they have like a workshop or have worked in industrial locations. So that's for big higher power stuff. So that's somewhere between slow and fast charging, but it's still that alternating current power. The type 1 takes 110 or 220 volt regular wall power. They call that single phase or split phase. And they're both governed by the same standard, the J1772 standard. The CCS is a combination charger. It has, you can see it has the type 2 and it has another 2 prongs below it. And if I yeah, and they usually, the car will always have access to the type 1, either through an adapter or a plug. And then it may have the type 2, and it may have the CCS, which is a fast charging plug. So you would usually pay for that option. And if you have that, then you can use either the type 2 or the fast charging in that one plug. And then the Chademo is a Japanese standard that Nissan and other Japanese manufacturers tried to push for fast charging. So they also still had the J1772 plugs. So that's a standard just globally, the J1772. You can see here, there's a picture of Tesla, which has its own proprietary plug because it's Tesla. And they also still have the J1772 type 2 there. And they could plug into a type 1 or type 2 charger. And then they could also plug into Tesla specific chargers. And now Tesla is starting to use the CCS on their vehicles and offer it on their charging stations as well. So there's a unification happening. But you can always charge at home or at the mall or wherever at a non-fast charge rate. Anywhere you go in the world will have J1772 as a standard. And the 110 volt plug adapter that comes with your car will be a J1772 adapter. And that's it. We've already been asking a lot of questions. And I want to say, if we don't have any more, I want to say thank you a lot to everybody for joining me for one or both classes. A lot of you came for both. And if you missed it, that was recorded and that's on the website. And I'm happy that we went a little bit longer on the presentation part here because of the great questions, which is fantastic.
And I want to thank Sean for this. It's a wonderful presentation. I think learned a lot. I actually might listen to it again.
Yes.
I'm glad we can record it. And on behalf of USS and Adult Enrichment, we thank you for these 2 sessions. I think we could probably have more sessions, but now we're only these 2. So I mean, I think we could go on and on with this. So,
yeah. Well, if people have a lot of questions, I guess I could cobble together another thing to address those questions and pull some more specific sources in. I wanted, both for time's sake and to encourage questions. I didn't want to be just tons of specific like cars, like model specific information. So you can email me or probably through Adult Enrichment, they can reach out to me too if you have specific questions. And then as I'm able, I'm happy to answer those too.
Sure. Oh, Sean, I know you explained this on the last thing you were talking about, a real quick question that the different kinds of charging that the different cars have, any of those will work when you go into a charging station, right? I think you said that, but
yeah. So this type 1 here, that's the circle.
Yeah.
That's like universal.
Okay.
If I were to take a picture of the one that's on the side of my house, that's what it is. So that's a big smart switch essentially that sort of plugs your car into the wall for you.
Well, I actually, we've had a little, if I'm interpreting what you're saying correctly, we have had some challenge finding that type 1 J1772 in some charging stations. For example, there's a fast charge station on 16th Street that has none of those.
Right. Yeah. So the fast charge. So there's like they would call it like AC charging, which is using that onboard charger that's in your car to actually convert the alternating current from standard wall power into the battery direct current. And then there's fast charging, which has an off-board charger that's much, much larger. And so what's actually going through the plug then is not alternating current, but the DC direct current. And it's directly charging your battery, which from the perspective of the car manufacturer is far more dangerous because they don't have a box that they built and put in there and programmed that's protecting. That's the thing that would go bad rather than your battery going bad, right? So they're governed by really strictly controlled standards, and all the fast charging companies have to get like stamps of approval from the manufacturers. But they all talk to the computers on the car. The car tells them how much charging to give me. The car tells them whether or not it even wants to charge at all. So it says, I'm ready or not ready to charge. It tells them in the case of like the type 1 or type 2, which are AC charging, not so they're still using the onboard charging. It tells them how much it expects to be using. And that's important because then the box goes, you're using more than you said. I'm assuming there's a problem and it disconnects. So it's like it unplugs your car from the wall basically, except with a switch. So there's a lot. So most of these things are around safety. You'll find that you can't touch live wires in the plug that's on the wall side. And that's another safety thing. So there isn't even a live wire actually until the car tells it to make live wire, but you can't like convince it and stick your finger in. You could, if you got really determined and you stuck like a paper clip in, you could do it, but like somebody's going above and beyond then. But so yeah, so it has the 3 big wires, the big circles inside the green one. So there's the 5 black circles there. The 3 bigger ones, those are the wall power connections, and then the 2 little ones are for talking to the car. And so that's the main distinction there. So yeah, so the fast chargers are deliberately not compatible with the AC charging plug. So that's on purpose, so that you can't, because you could cause a lot of problems to your car if you could somehow switch it. So you have to make, that's a one use. If anyone who's in design, there nothing is idiot proof, is what they would say. Like, you underestimate the ingenuity of fools, is a line that a lot of people like to say. So
I just wanted to make sure that you weren't going to a charging station and you can't, and then it doesn't hook up, or it doesn't. It's not compatible.
And fast charging is a popular one to add first, even though it's really expensive for like the store or whatever that adds it. And the reason they like to add it first is that's the one people tend to use the most, even though they don't necessarily need it. They get the most electricity out in the shortest visit. So particularly grocery stores and malls like to add that. Mm-hmm. A lot of malls or places that added the regular 220 volt chargers, they did so before fast charging was actually really an established standard. And so even though there was an on paper standard for cars didn't really exist that could use it, and there wasn't companies supplying the equipment, and so they put in what there was. But yeah, it can cost that landowner can pay $15,000 to $40,000 to put in one fast charger, and then that doesn't even account for often having to upgrade the grid connection, and that's installed. That's like assuming they don't have to like dig up an entire parking lot to do it. It may cost them $2,000 to $5,000 per 220 volt plug they put in. And that's mostly permits and having to trench and add wires and stuff like that. It's big. The actual box itself is like about $500 or something like that. So it's not a small investment, especially if they're giving you free electricity on top of that, and they don't know how much extra dollars from EV owners are going to get. It's still a big unknown for them. So they're kind of gambling.
Yeah. Okay, I think unless anybody's got any quick question they can ask, I think that's probably about wraps it up for this evening. I think our time is about 8:30. And thank you everybody for coming tonight. We really appreciate that, and it will be available. The second session will, as well as the first one, will be available recording at uuss.org. And thank you especially for Sean. This has really been informative. A lot of information. And I think we might have only scratched the surface. Is that right?
Yeah, you can always. So I'm going to also share the presentation. And I put some good entrances to the rabbit hole there for people if they want to. So like the Reuters and CNBC article in particular are a good diving off point. If you want to dig into more and more and more about how green is your vehicle over its entire life.
Mm-hmm.
So I encourage you to explore as much as you would like to explore.
Great. So yeah, it'd be great to have these. We want to have people write these down, or is there?
Well, I think I can post these in chat here really quick, but
Okay.
I'm going to give the presentation to Crystal to post.
Oh, okay. So we'll post it and people can click on it or.
Right.
Yeah.
Exactly. In the slideshow. But I'll post these in chat really quick here for everyone who's hung on.
Good night, everybody who's leaving.
Let's see. There we go. All right.
So we can just click on any of those. Okay.
All right. Any additional questions?
Okay. Well, thank you again, Sean, and everybody for coming. With a couple of us still left, so this has been great, and we thank you for sharing your experience. All right.